In this slidecast we're going to look at estimate adjustment. In our previous slidecast we looked at how to calculate the cost based on historical figures. Now we're looking at how do we adjust that cost. We need to make adjustments for different factors which are listed here. The first one is size. Economies of scale mean that it costs less per square meter to build a 10-kilometer road than it does to build a 100-meter driveway. So the 100-meter driveway, it might cost $100 per square meter to build it, whereas the 10-kilometer road might be $80 per square meter to build. So the bigger project is obviously more expensive overall, but if you look at it on a per square meter basis, it's a lower rate. And that's because you can use bigger machines on the bigger project, you can use more efficient work methods, you have more time to learn how to do it properly. So the word for that is economies of scale. Another thing that might need to be adjusted is time. As you're aware, prices go up. So something built in 2010 is going to be more expensive to build exactly the same thing in 2013. Something built during the summer is going to be cheaper generally than something built in the winter, because the project built in the winter is going to be exposed to weather. So you've got to adjust. So if you were doing an analogous estimate and you based it on a project built in 2010, you need to adjust that price, that estimate, to allow for the fact that it's now going to be built 4 years later in 2014 or whatever it is. There are other things such as labour and material market. If there is not much work in the market, then all of the contractors and suppliers are all competing for work, and they're going to offer lower prices. If there's lots of work, then they're not going to be as keen to get the work. They're going to put a little bit more profit on, knowing that they can get another, that there is plenty of work there for them. So it all depends on how the economy's going. When the economy's got lots of work, then prices are a little bit higher. When there's not much work, prices are a little bit lower. Location and land cost. Something being built in Auckland is going to cost more than something being built in, say, in Te Awamutu or a country town, because there are lots of things associated with Auckland. Auckland land costs are much higher. More traffic in Auckland. It takes longer for trucks to get to and from places in Auckland. There are all sorts of factors. And the last one is standards, quality. It might be that you are designing something that has really high standards, has a very high level of materials and workmanship. It might be an architecturally designed building which is using special woods, which requires special workmanship, which is going to take longer to do, and it's going to cost more as compared to, say, just a normal house. So materials, features, facilities, all of those things also need to be adjusted. So what we're going to look at, the two things that we need to adjust in our course is size and time. We're going to look at both of those now. So size adjustment is, you've got a project that has already been built. That's the base project. And you've got a project that's about to be built, and that's the new project. So you know how much the base project cost, the old project, and you need to figure out, well, how much is the new project going to cost? And this is the equation you use. You've got the old project cost, and then you need to adjust that cost to allow for the difference in sizes between them. And the way you do that is the size of the new project over the size of the old project. Now you could just do it like that, but that's going to end up being a little bit too conservative. One way to make it closer to reality is to take that ratio there and times to the power of 0.75. A friend of mine did a master's degree in studying prices, and he took a whole lot of prices of work that was done and how they would be best adjusted for size, and he figured that this was the way that it works. So this calculation here, this equation, is empirical. It's just based on previous projects rather than any sort of mathematical concept. time adjustment. Costs increase over time, and how do we adjust for that? And the way we adjust it is by using a price or cost index. These are things that are put out by the Department of Statistics, and what they do is they analyze prices for a certain thing at a certain time, and they equal that to an index, and then every quarter, every 3 months, they go along and they reprice it, and they see how much has that price gone up. So it's an arbitrary number representing a particular type of work. In the case of engineering, we have a producer's price index, the PPI, for construction. So if you go to Statistics New Zealand, you will find the construction PPI. And what happened there was the Department of Statistics looked at the prices of certain construction things, I think it was in 2010, and they figured out it was going to cost a price, let's say $100 million. So they said, well, that $100 million is equal to an index of 1,000. And so every quarter they go along and they reprice those different types of work, and then they equate them to that index. So by dividing the index at that particular point in time to the base index, you're able to calculate, you're able to make adjustments for the time. There are two PPIs that are of interest to us. The input PPI measures the input costs to construction, in other words, contractors' costs. So it measures the cost of labour. It measures the cost of buying materials to do the work. So that's what the input PPI. The output PPI is what the price that is charged by contractors is. So this is the cost to the client. The input PPI is the cost for the contractor. The output PPI is the cost to the client. So if you were a contractor, you'd be interested in the input PPI. If you're a client doing an estimate, adjusting a price, then you are interested in the output PPI. So we need to adjust it using this equation. Unfortunately, it's dropped off the bottom there, so it's cost required. So the cost of the new project, the cost of the old project, the one that you already have a price for, times the PPI of the new project over the PPI of the base, and that sort of just dropped off the top. So that ratio there is an adjustment. So you're just taking this price and you're adjusting it for time changes. Now here's the PPI for the last few years. You can see it from December 2009. In December 2010, that's when they set the base price of 1,000. Before that, they had I think it was 1999, their base price of 1,000, but they keep on adjusting them. So in this case, 971. So there's the index. In December 2010, they looked at a whole lot of construction work and they said it's going to cost this much money. We'll call that a cost index of 1,000. And you can see that the prices have steadily gone up. So you can look at this and say that between December 2010 and March 2011, the costs of construction have gone up by 1.2%. So if you put 1,012 over 1,000, you end up with a 1.2% increase. So it's been steadily going up by about 1.2% up until June 2011, and then the recession hit. And you'll recall that there was all sorts of there was not much work in the workplace, and you can see that by this line actually leveling out. So whereas things were going up at about 1.2% every half year, all of a sudden it all started leveling off, and it was only going up 0.3% by the looks of things. So that shows the economy is sort of starting to tank because of the recession. Now there are several ways that we can look at this. Now when we are pricing up a project, we're pricing it into the future, so there aren't any PPIs available for it, so we need to extrapolate the lines. And there are several ways we can look at this. One is this blue line here, where you can sort of take the trends over a period of time. In this case we've taken from 2009, and we've just extrapolated a trend out, which is the blue line. Or you can take it over the last few months, which is the red line. And what that shows is there's a difference. So if you were pricing up something for December 2013, you could have a PPI of 1070, or you can end up with a PPI of about 1100. The blue line, this is going to render a price that's a little bit higher than this one here, so it's going to be a bit more conservative. Personally, I'd use the blue line. If you think that the economy is going to keep on tanking and is going to keep on growing at this lower rate, then yes, you could use this. If you're a bit of an optimist and you think that this is just a temporary blip, that it's going to sort of come back to that normal rate of growth, then you use the blue line. So there's a bit of judgment involved in determining what the appropriate PPI is going to be. The last thing I wanted to show you is that this cost adjustment is also included in NZS 3910. In NZS 3910 there is an allowance for the increases in price to be included in the contract. Now there's something in special conditions where you say that cost adjustments are applicable, and most contracts say that they're not, but if they are and the costs go up over time, then this equation here is used, and it's not as complicated as it looks. It's really two things. So what it's doing is there is a labour one, so that there is the labour cost index, and that there is the PPI for materials. So the two things that can affect the cost of construction are labour and materials. So if the cost of labour goes up, then the contractor would be able to charge more than what he actually tendered for. Likewise if the materials go up. And the way they've weighted it is 40% for labour and 60% for materials. Really this is just shown to you out of interest that this is actually used in industry sometimes.